Determine the points where the curves r equals 1 and r equals sine 2 theta intersect. I always think it's a good idea to draw a very quick sketch of these. R equals 1 is just going to be a circle of radius 1 centered at the origin, or the pole. Okay. Sine 2 theta, if we do a quick sketch of that, it's a little something like this. It's one of these nice flowery shapes, sort of like a rose. Now, I don't know if it sticks out this much, or maybe the loops are too small, or maybe the loops just touch. But just based on a quick sketch, it looks like we could have up to 8 possible points of intersection. Of course, we need to do the math to back it up. Maybe the loops are smaller than I'm drawing, or maybe they're exactly right so that they just touch, in which case maybe we get 4 intersection points or no intersection points. Okay. Now, when I'm working out points of intersection, the first thing I look for is the pole. And this corresponds to r equals 0, and I ask, can we have r equals 0? Is there a theta value that makes r equals 0 for both of these? Okay, and there is for the sine 2 theta curve, but you'd need 0 to be equal to 1 for the circle, and so that's just not going to work. So the pole is not on both of these curves. So the pole is not a point of intersection, which makes sense because when I drew the red circle, it did not go through the pole. Okay, so then what do we do? Well, then we should set up equations. So both of them having the same r value, and their theta values differing by an even multiple of pi. Of course, r equals 1 doesn't really care about its theta, so we can just set up this equation. Or the r values being negative of each other, and the theta values differing by odd multiples of pi, which again, we don't need to worry about that last part because the circle r equals 1 doesn't care about its theta value. Now, what do I put into sine to get 1? Well, pi by 2, or 5 pi by 2, or 9 pi by 2, and so on. And if we divide these by 2, we get possible theta values of pi by 4, 5 pi by 4. We could go with 9 pi by 4, but that would have gone once around the circle and be back to where it starts. Okay, in fact, both sine 2 theta and 1 are periodic, and they repeat every 2 pi, so we really only need these ones. But if you want to write out 9 pi by 4 and 13 pi by 4, go ahead. Okay. When does sine equal negative 1? Well, when our input is something like 3 pi by 2, or 7 pi by 2, or 11 pi by 2. And these correspond to theta values of 3 pi by 4, 7 pi by 4. We could do 11 pi by 4, but that's just 3 pi by 4 plus 2 pi. Gone around the circle again. We don't need to worry about that. Okay. So these values here should work out. And if we plug them into our curve, we'll do the sine 2 theta one, we can see that our points are 1 pi by 4, 1 5 pi by 4, negative 1 3 pi by 4, negative 1 7 pi by 4. Okay, 4 points of intersection, which means I did draw my curve a little hastily. Okay, a proper picture would be something like this, where it just touches at pi by 4, comes down here on the negative side, just touches at negative 1 in the 3 pi by 4 direction, just touches at 5 pi by 4, just touches at 7 pi by 4, but it's negative 1, we're in the opposite direction, because 7 pi by 4 as a direction is down here. And then you've gone a full 2 pi, we loop back to where we start. Okay, so we get 4 points of intersection, and I think that's all we asked for. Determine the points where they intersect. Well, there's 4 of them, and we gave them expressions.